Welcome to Unit 2, Lesson 1. In this unit, we're skipping ahead a few chapters in the textbook to Chapter 10 on the concept of utility and consumer choice. We are going to be analyzing consumer behavior using this concept of utility, which, as you've read about, is kind of an idea of the satisfaction or pleasure that you receive from consuming a good. And while it seems like a very subjective kind of measurement, and it would be if we tried to actually put numbers on it, really we use it more conceptually to talk about what kind of behavior consumers typically exhibit when they're making choices about what to buy and what not to buy. So when we talk about the utility from consuming something, we're talking about the satisfaction or pleasure that somebody gets from consuming it. So the example that you've got in front of you with these numbers and graphs, and which I've just copied out of the textbook, is somebody eating. It's got a plate full of fried clams in front of them. I don't know if you're all somebody who likes fried clams or not, but they're little things. You could pop a couple of them into your mouth at a time. You could eat a bunch of them in a whole sitting, like them. And they give the example of somebody eating. If they ate the first fried clam, then the total utility they would get from that clam, let's call it 15, and the units on that is just 15 utils. Which sounds silly, but that's what we call it. So he gets 15 utils from the first clam. That's the total utility that he's gained from, or she's gained from consuming clams up to that point. And we'd also call that the marginal utility of that first clam. It was 15 additional utils that were gained from consuming that first clam. Then Cassie decides to consume a second clam, and her total utility increases to 28 from 15 like it was before. So the difference between those, it's an additional 13 utils was the marginal utility she got from that second clam. And so on down the line. You can see with each additional clam, Cassie's total utility increases, at least all the way up through the 8th clam. And that goes along with an additional marginal utility of some amount for each additional clam she consumes. But the key pattern here, this term up here, diminishing marginal utility, refers to the fact that on this column, you can see that each additional clam brings a little bit less utility, less additional utility than the one before it. And again, very intuitive sense here. If you're hungry, you like fried clams, you sit down, the first one, that is great, gives you a lot of satisfaction, pleasure, happiness for consuming it. The second one, also good, but man, that first, not quite as good as the first one. If you were really craving them, that first one's going to be the best. And then so on. Each one's going to bring you a little bit less pleasure until you hit, notice on this column, at the 9th clam, that 9th clam brought Cassie -1 utils of utility, which means that really she would rather have not eaten the 9th clam. If she does, she's going to wish she hadn't. So that's what negative utility means, and which just kind of follows if she's getting less and less utility from each one. Eventually, the way food works, you're going to get dissatisfaction from eating too much. Okay, so that's an example of diminishing marginal utility. We could use so many different goods that we could kind of give the same story about. You start eating potato chips out of the bag. The first one gives you more than the ones before that. You start watching DVD of your favorite TV show. The first episode gives you a lot of satisfaction. You probably want to watch the second one if you have time, and so you will, but it's diminishing marginal utility from each additional one. Almost any good we could put that kind of story on. So diminishing marginal utility is we're going to give it as a general assumption for most goods. It's not a law, strictly speaking, but it is a kind of typical consumer behavior to get diminishing marginal utility from most goods. So that's pretty simple. Let's get into the graphing of this, because this is what is can be a little more confusing or complex, and what we're going to use a lot over the next couple of units. So we've got two graphs that are shown here that both come from the same data table on the right. The graph on the top we're calling Cassie's utility function. We could also call that just the graph of her total utility, or TU. And this is a graph of these two columns here. The quantity of clams, the column left, is on the x-axis, and the total utility is on the y-axis. So we saw the first clam gives Cassie 15 total utils. Second clam, she's got 28 total utils, etc. And so that's just a graph of those two columns. Let's look at a couple things about the shape of this graph. If we were to just kind of sketch it out, it's not a straight line. Let's draw it on its own separately. It kind of looks like that. That's the shape of it. There's a significant thing about this shape. We could say, for one, up to this point, from 0 up to that point, which is, the point is 8 clams, she's getting increasing total utility, but diminishing marginal utility with each additional clam. So that means we could also say the increasing total utility is increasing at a decreasing rate. You could also say the slope of this is getting flatter if you wanted to think of it in those terms. So it's increasing at a decreasing rate, which is just, again, another way of saying that the marginal utility is decreasing, that each additional clam is giving her less and less additional total utility. Again, when she hits the 8th clam, it's kind of like a point of inflection where beyond there, her total utility starts decreasing as she eats more and more clams. Remember that 9th clam gave her -1 utils. You can see that here. It's not quite as clear from this graph. But her total utility starts decreasing at the 9th clam. Let me jump down to a new spot here. Let's take a few goods that might exhibit slightly different patterns of total utility than this. And this will, I think, help us see kind of the significance of this, or the differences at least. So we said that clams exhibit this kind of total utility. What about clams compared to something bigger like porterhouse steaks? What would be the difference, do you think, for the graph of consumption of porterhouse steaks? Those are big steaks if you're not familiar. Basically, we would assume that, okay, the utility would start getting negative quite a bit earlier. It'd probably go up higher because most people value steak more than a clam. So it would probably start out higher but quickly diminish a little bit more quickly than the clams. So the difference here, it's still increasing at a decreasing rate, but it's more quickly hitting that point of inflection where it starts to diminish, and then it diminishes a lot faster than the clams. Like the 3rd and 4th steak's probably going to give you a lot of negative utility. Here's another one. How about, let's go with video games. And say that you have bought a new video game and you're just kind of learning how to play it, and you're pretty bad at it at first, so it's kind of frustrating. Every time I go to my brother-in-law's house, and that's the only time I ever play the game Call of Duty, and he just embarrasses me. So at first it's not terribly fun. As you play a game more and more, if you're experienced enough with this, then you end up getting more and more kind of enjoyment out of it the more and more you play, at least up to a point, and then you probably hit diminishing margin utility. But the total utility you would get, at first would kind of be pretty moderate, and then as you get better and better, each additional game that you play gives you more and more total utility, maybe even at a faster and faster rate as you're getting really good. So here's what I'd call utility from maybe a new video game. That's increasing at an increasing rate. That's different than the ones we've seen before. And then how about one more? Video games is actually more of a when I was young experience for me, but music is still something that I get a lot of satisfaction and pleasure out of. So I would say that there's a lot of, there's so many things I want to listen to out there that, if I had unlimited budget for CDs, I could keep buying CDs and listening to them, unlimited budget time with basically steady enjoyment throughout. I just get as much enjoyment of the second one as I did out of the first one, and third one, same thing, fourth one, fifth one, sixth one. I could keep going. You get the point. My total utility for that would just look like this. It'd be a straight line, constant upward slope. where my total utility would be increasing for CDs at a constant rate. Okay, so hopefully you're seeing some of the differences there. The total utility of clams increasing at a decreasing rate, then eventually becoming negative. Total utility of steaks increasing at a decreasing rate more steeply and then quickly becoming decreasing total utility. The video games, increasing rate, CDs, constant rate, and how the shapes of those graphs kind of line up. Okay, now let's look at the second graph on here. We'll come back to these and draw second graphs for those too. So these two graphs that the book has given us, the utility function on top and the marginal utility curve on bottom, are closely related, and there's a significance to why they're drawn one above the other. So the marginal utility curve graph is a graph of now the marginal utility column here and the quantity column. So these two columns are graphed on this one on the bottom here. So for instance, with the quantity of clams, with the first clam, we said the first clam gives a marginal utility of 15 utils. The way we graph marginal data is to put the x-axis values in between the points. The reason for that is the way that it lines up with some of the average curves that we'll see in later chapters. It's not super significant now, but later on it will be, so just get in the habit now. Whenever you graph a marginal anything, then put the points midway in between the x-axis values. So for that first clam, Cassie got 15 utils. For the second clam, so we put that in midway between the first and second on the x-axis, that's 13 utils, and so on. Okay, so what do you notice about this graph here? For one thing, it is decreasing at a constant rate. The fact that it's decreasing shows diminishing marginal utility. It happens to be a constant rate. It's not always, but it happens to be a constant rate, and you can see it from the numbers. It decreases, the marginal utility decreases by 2 every time. So that's the constant rate there. That's why it's a consistent slope all the way through. But basically that's just showing diminishing marginal utility. Notice after this 8th clam, or upon eating the 9th clam, it gets negative. It crosses through this it crosses through there to where it gets onto the negative part of the y-axis, and you start to get negative additional utility or reduction in utility from additional quantities consumed. So notice how this lines up with the graph on top. Let me draw a thing like that. Remember I said that 8 was kind of like the point of inflection of this total utility function, where at that point it starts diminishing the total utility. Well, that's also the point where the marginal utility starts getting negative. So that in this entire region here, all the way up till 8, marginal utility is positive but decreasing. And so that's why you get this total utility curve. It's increasing but at a decreasing rate. That goes along with marginal utility being positive but decreasing with each additional clam. If you're calculus minded, something that might help with this, if you haven't noticed already, is that the graph on bottom is a graph of the derivative of the function on top. You don't need to know that for this class. It's just one of those things that if it helps you think about it that way, then more power to you. One other way of thinking about it is that the marginal utility graph is a graph of the change in total utilities. Again, the same, it goes back to that calculus and derivative concept. It's just, if you're not familiar with that, you don't need to think of it that way. Okay, so let's go back to these graphs and create marginal graphs for each of these. Okay, so we already know clams because that's up there. So it's constant and then it hits that point of inflection. That should line up with that point of inflection there, where marginal utility gets negative. So how would that look different for steaks? Well, we just have a more steeply diminishing. It would be higher to start off with, but we'd have a more steeply diminishing marginal utility curve, and it would get negative quicker. which I didn't do a great job of showing there, but that would be the comparison of this one to this one. This one would be steeper and get negative quicker for stakes. How about for video games? The marginal utility for video games, if it's increasing at an increasing rate, we've got positive marginal utility all through here, and rather than diminishing marginal utility, we've got increasing marginal utility. So that one kind of breaks the rule, so to speak, of diminishing marginal utility. I mentioned that's not a hard and fast rule. There might be some things that don't exhibit diminishing marginal utility. So there's an example of one that might not, at least for a while. And for the CDs, if you've got total utility increasing at a constant rate, then your marginal utility looks like this. It's positive and it's constant all the way through. If you want to put it in terms of numbers of utils, say that each CD gives me 10 additional utils. Our values here are 10, 20, 30, and so on. Down here it's just 10, 10, 10, 10. Each additional CD gives me 10 utils. My total utility is building at this constant rate. My marginal utility is constant at 10 utils per CD. Okay, I'm going to stop there. We're going to do some more things with utility next, but I hope this gave you a good kind of starter on getting familiar with working around with these total and marginal graphs and the relationships among them. See you in class.